chain. So in our first food chain, we move from the sun to diatoms. From diatoms, we move to copepods. And from the copepod, we move up to a duck. That is a food chain. We are moving from one organism to another. Can you spot another food chain? We start at the sun. We can move up to algae. From algae, we move to shrimp. And from shrimp to duck. Or you can go directly from the sun to algae, algae to copepod, copepod to duck. Each of these are food chains, but when we put them all together, it creates a food web, and a food web is actually a more realistic representation of how energy flows through an ecosystem. Very rarely do organisms ever eat just one type of food, because you want to survive, and if your main purpose is to survive, you're going to make the most out of all of the resources that are around you. So, for instance, copepods don't just eat algae, they also eat diatoms. And ducks don't just eat copepods, they will also eat shrimp. That creates a food web. And then after all of this, we have our top consumer, which is the sea lion. Okay, the energy from most food webs originates from the sun. That solar radiation that we are lucky enough will travel through the vacuum of space in order to reach the surface of our planet. Photosynthesis is the process by which producers capture the solar energy and convert it to chemical energy in the form of sugar. And that sugar is known as glucose. So this chemical equation should look familiar to you after learning about photosynthesis in the climate unit. Carbon and dioxide plus water in the presence of sunlight is converted to starch in the form of sugar and oxygen inside of plants. So for plants, carbon dioxide is the nutrient, and water is as well. They take carbon dioxide and water, they convert it to glucose, which is energy for us, and then oxygen as a waste product by the plants, a vital nutrient for humans and most other living organisms. Okay, so this is looking at a food pyramid or an energy pyramid. And the reason why this is a pyramid is just showing the amount of energy at each of the four trophic levels, starting with the producers, of course, which are the plants, the primary consumers, secondary consumers, and then the tertiary or top consumers. Now, there's a reason why this is a pyramid. The pyramid is actually demonstrating the flow of energy from one organism to another, and what it's doing is showing the loss of energy as the energy moves up the food web. So 90% of energy is used by an organism or is lost as heat. So what this means is 10% of the available energy is moving up to the next trophic level. This is what we know as the 10% rule. Only 10% of energy can be transferred to the next energy level. So we start with producers, these plants. Only 10% of the energy produced by these plants is going to be transferred to the grasshoppers. Only 10% of the energy available in the grasshoppers will be then transferred to these birds. And only 10% of the energy in the birds is going to be transferred to this hawk. That is known as the 10% rule. And what that rule does is it actually helps to create balance within an ecosystem, and I'll explain why. All right, so why are there fewer harbor seals than anchovies in the San Francisco Bay? Why don't we have as many harbor seals as we have anchovies? Why do you think? 90% of energy is lost at each level, so there isn't as much energy available for top consumers. Also, it is easier to get food as a producer, so population numbers are higher. So think about plants. They're autotrophic. They don't have to go out and hunt to get their energy. They just stay in one place, they absorb sunlight, and presto, they have breakfast, lunch, and dinner. They're not expending a lot of energy in order to make energy. But if you're a consumer, you have to actually go out and hunt your food, and hunting food uses energy. Additionally, if you're a top consumer, you're going to require more energy in order to survive. Thus, there has to be enough organisms at lower levels of the energy pyramid in order to support the top consumers. Therefore, there can't be as many top consumers as there are first consumers and secondary consumers, because 90% of that energy is being lost at each level. There's only 10% available to the next level. So why would more agricultural land be available to provide food for the growing human population if humans didn't eat meat? If we were herbivores instead of omnivores or carnivores, why would more agricultural land be available? Well, it also has to do with the 10% rule. So we have person 1 who eats, we'll say, 10 servings of grain. Or they can eat 10 servings of cow. It's the same amount of energy. It's 10 servings. However, that cow had to consume 100 servings of grain before the cow could be fed to the person. So a person gets the same amount of energy from eating the same amount of either meat or grain, but because of the 10% rule, much more grain will be used if the person eats the cow for energy. Making more grain uses land and resources that could be available to feed more people. So this person has the option of just eating the grain directly, or the person can take the grain that they themselves could eat and feed it to a cow, and then eat the cow themselves. But the problem is that it requires, 1, more land because there has to be more grain to feed the cow, but then you also need land on which to grow the cow. So it's really twice the amount of resources. It's more than twice the amount, but you need more land, more resources to grow both the grain and the cow. So let's take a look at an example of the 10% rule.
Look at this brave little piece of grass, facing the dangers of the wild all by itself. But don't worry, because in reality, this grass isn't alone. The 10% rule states that producers of a piece of grass have 90% more biomass altogether than consumers, the cow. What's that? You don't know what biomass means? You don't know what the 10% rule is? Well, don't worry. I know someone who can explain it.
The 10% rule is an approximation of the amount of biomass passed between trophic level. Whoa, that was a lot of big words. Let's go over them. Biomass is the total mass of something minus the mass of the water. A trophic level is basically just a level of a food chain. Let's use the cow example from before, but let's replace humans with bears. We can symbolically place grass, cows, and bears on different levels. The grass is a producer in this system, meaning that it harvests energy and matter from sunlight and its surroundings. The cows eat or consume the grass. For this reason, they are called consumers. Because they are the first in this food web to eat something else, they are called primary consumers. This bear eventually eats the cows. Because it is eating a consumer, it is called a secondary consumer. Now, when you line up the trophic levels, it forms a pyramid known as the energy pyramid. Wait, who said anything about a pyramid? Trophic levels form a pyramid because of the 10% rule. Remember that? Remember biomass? No? Let's recap. The biomass of something is the total mass of the thing minus the mass of its water. The 10% rule states that when something eats or consumes something else, only 10% of the biomass is transferred. But wait, what about the other 90%? That 90% is burned off by the consumer for energy. This means that only 10% of biomass moves between trophic levels. So, why is each trophic level smaller than the last? This is because, for an ecosystem to last, each trophic level must have 10 times the biomass of the following level. Think about it. How much grass is there compared to cows to bears? For every one bear, there's 10 times the biomass of cow. And for every one cow, there's 10 times the biomass of grass. Now, how could this apply to humans? Let's take a vegetarian and a carnivore. The vegetarian only eats grass, and the carnivore only eats steak. To get his or her portion of food, the vegetarian must consume one serving of grass. The carnivore must consume one portion of steak, which seems like the same amount of food. However, they are thereby consuming 10 times the grass because they are being secondary consumers. So what if we all became vegetarian, or at least part-time? Every meal of veggies would cut down on the resources used to 10%. If we had that much free food, no one would go hungry. So what will you do?
And that is a simple explanation of the 10% rule. I hope it helped you to better understand it. Welcome to Ecology.